This regular hexagon is equilateral and equiangular. What does that mean? It means it has equal sides and equal angles. All sides are equal, all angles are equal. That makes this nice perfect polygon. Looks perfect, right? So what I want to do is I want to just kind of, in this chapter, I'm just going to kind of give you a few angle measures, but in the next chapter we cover, we're going to actually determine how to find the angle measures in any regular polygon. But for right now, what we're going to talk about is a regular hexagon. And there's a reason for that, right? So I'll get to that right now. In any regular hexagon, all 6 sides are the same, all 6 angles are the same, right? Now, in any regular hexagon, all of the angles are 120 degrees, right? And I can go all around this figure, but I'm going to save some time. Now, what we're going to do is, we're not going to learn this whole new, extravagant formula. What we're going to do is this. We are going to draw our diagonals, okay? So I'm just going to connect opposite vertices, right? Opposite corners. And once I draw my 3 diagonals, you'll notice they meet in the center and they perfectly divide this regular hexagon into 6 equilateral triangles, okay? How do I know that they're equilateral? Well, think about it. If this was 120 and this is a nice, perfect regular hexagon, well, then those 120s will be bisected into 60 degrees, okay? 60 here, 60 here, 60 everywhere, right? So even in the middle, even in the center, I know this is 60 degrees, this is 60 degrees, so that's going to make this 60. But just to give you another reason, another way of thinking about it, if I go around the center here, right? If I go all the way around, that's going to form 360 degrees in a circle. And if I just divided it up into 6 pieces, 360 divided by 6 will also give us 60 degrees. Okay? So guys, this is the most important part. We're going to have 6 congruent equilateral triangles put together to make up this area. So all we have to do is find the area of one and then simply multiply it by 6. All right, and that's going to be our game plan. So we have done this before, all right? Not the hexagon part, but the equilateral triangle part. So let's go read our directions. Let's get going here, right? Find the area of a regular hexagon with a perimeter of 36 feet. Now let's be careful here, right? That 36 feet is all 6 sides of this hexagon. So if I want the length of one side, I'm going to take 36 divided by 6 and get 6, okay? So that's going to be the length of this side here, 6 feet. Now, since this is a regular polygon, right, regular hexagon, this is going to have all 6 equal sides, right, 6 all the way around, okay, and then also the same angles. All right, cool. Now in the middle here, right, on the kind of bottom middle here, if this is an equilateral triangle, then all sides are 6. And as a matter of fact, I can literally go all the way around. Every side length on here is 6 feet. Okay, just for simplicity, here's what I'm going to do, okay? I drew a separate one down here, okay? So let me get this on here. So I have my 60 degrees, my 60 degrees. Now, guys, we're going to draw our height here, okay? Perpendicular to the base. Each side was 6. Base gets bisected into 3 and 3, which is still 6, right? And then that's going to bisect this into a 30, 60, 90. Very good. Now, ready to go here. Don't forget that this is usually our 2x side, this is our x side, and this would be our x radical 3 side. So, ladies and gentlemen, we're going to take our short leg here, we're going to multiply by radical 3, and we're going to get 3 radical 3. All right, cool. So here we go. So this equilateral triangle by itself is going to have an area found by using 1/2, whoops, a little sloppy, 1/2 times the base times the height. All right. I'm going to tweak this formula in a second, but let's just go ahead and go through the motions. So my area of only this one equilateral triangle will be 1/2 times the base. Now remember, guys, the whole base, right, is going to be 6. And now we found the height to be 3 radical 3. Okay. So if we continue to go through our formula here, right, I'm going to have 1/2 times 6 times 3, which is going to be 9 radical 3. Okay. So that means the area of one of these equilateral triangles, right? This equilateral triangle all by itself is or has an area of 9 radical 3 feet squared. Now think about it. If this is 9 radical 3 feet squared, then this is 9 radical 3 feet squared, and so is this, etc., etc., etc. So here's how we're going to tweak our formula. All right. In order to find the area of the entire hexagon, I'm actually going to go delete these capital A's for a second. Right? If we want to find the area of our entire hexagon, guys, what we're going to have is 6 times 1/2 base times height, right? Because there are 6 equilateral triangles. So if I do this, you know what, maybe I'll even, I'll use parentheses here. In here will represent the area of 1 equilateral triangle, and then we're going to multiply it by 6. So here we go. Let's finish this up. Right? So now at the end, if one of those equilateral triangles was 9 radical 3, then the area, I'm just going to put a little subscript here, then the area of the hexagon will be 54 radical 3 feet squared. Okay? So in summary, what we've done is we took our regular hexagon, we drew the 3 diagonals and split it up into 6 equilateral triangles. We found the area of 1 equilateral triangle, and then we multiplied it by 6. All right, ladies and gentlemen, I hope this makes sense. I will talk to you soon.